Right now, this very second, as you watch this video, something is happening deep beneath the African continent. Something scientists are calling one of the most disturbing geophysical mysteries of our time. No government bulletin has warned you. No emergency broadcast has sounded. It is silent, invisible, and it has been building for millions of years. Nearly 3,000 kilometers below the surface, at the boundary between Earth's scorching liquid core and the rigid mantle above it, lies a colossal mass of ultra-dense rock. Not a small anomaly, a structure the size of a continent, rising 900 kilometers tall, utterly unreachable by any drill or probe ever built. Scientists call it the African Large Low Shear Velocity Province. Among themselves, they call it the blob. And the blob has been doing something for a very, very long time. It has been weakening Earth's magnetic field. That invisible shield, the magnetic cocoon protecting all life on this planet for billions of years, is losing its grip. ESA satellites have been watching in real time, and what they have recorded over the past decade has made geophysicists quietly, measurably nervous. The zone of weakness has expanded by an area equivalent to nearly half the European continent in just 11 years. 11 years, not 11,000. 11. Conspiracy theorists are already screaming about pole reversals, continental shifts, alien bases, and the end of civilization. Scientists are speaking more carefully, but beneath the measured academic language, there is something harder to disguise than excitement. It is concern. Today, we go all the way down, through exactly what is hiding beneath Africa, why it is growing, what it is doing to our satellites, our power grids, our atmosphere, and possibly to life itself. Part 1. The Invisible Engine. How Earth's magnetic field actually works. To understand what is going wrong, you first need to understand what is supposed to be going right. Most people know exactly one thing about Earth's magnetic field. Compass needles point north. Behind that simple observation hides a mechanism so colossal, so intricate, so poorly understood even now, that physicists who have dedicated their entire careers to it will tell you, with complete sincerity, that we are still guessing at the details. Picture the core. At the very heart of Earth sits a solid iron-nickel sphere, roughly the size of the moon, approximately 2,400 kilometers across, heated above 5,000 degrees Celsius, hotter than the surface of the sun. The pressure holding it solid is not temperature, but pure gravitational force, over 3 million times atmospheric pressure. Surrounding that inner sphere is the outer core, an ocean of liquid metal approximately 2,200 kilometers thick. Iron, nickel, traces of sulfur, and oxygen in constant churning motion. The heat from the inner core warms the base of this liquid, driving it upward. It rises, cools, sinks, warms again. The same convection you see in a pot of water, except the pot is 6,000 kilometers across, and the water is liquid iron. As Earth spins, the Coriolis effect twists those rising and falling plumes of metal into spiraling columns, organizing the convection into something far more structured than a simple boiling pot. Here's where physics delivers one of its most elegant and terrifying tricks. When an electrically conductive fluid moves through an existing magnetic field, it generates electric currents. Those currents produce new magnetic fields. Those fields redirect the fluid. New motion generates more currents. More currents make stronger fields. The whole system feeds itself, amplifies itself, sustains itself. Physicists call this the geodynamo, a self-sustaining generator the size of a planet. This generator has been running for at least 3.5 billion years. What it produces is the magnetosphere, a vast asymmetric bubble of magnetic influence extending 60,000 kilometers toward the sun, shaped like a teardrop blown back by a hurricane wind. That hurricane is the solar wind. The sun is constantly, violently shedding itself. blasting charged particles outward at 400 to 800 kilometers per second, every second, continuously. Without the magnetosphere, that stream would be lethal. It would strip our atmosphere the way it stripped Mars's, molecule by molecule. Mars almost certainly had a thick atmosphere, liquid water, and perhaps the conditions for life. Then its magnetic field died. The solar wind spent the next few billion years eroding everything. Today, the Martian atmosphere is less than 1% as thick as Earth's. The oceans are gone. The surface is a frozen, irradiated desert. Earth's magnetosphere is the reason that fate has not befallen us. When the solar wind strikes the magnetosphere, it is deflected, flowing around the planet like water flowing around a stone in a river. The most energetic particles do penetrate along the field lines near the poles, spiraling down into the upper atmosphere where they collide with nitrogen and oxygen molecules and release energy as light. That is the aurora borealis and the aurora australis. That is what it looks like when Earth's shield is working exactly as intended. But there is one place on Earth where the shield is not working as intended. One place where it has never worked quite right. One place that, in the past decade, has been getting noticeably, measurably, demonstrably worse. That place is the South Atlantic Anomaly, and it is the center of everything that follows. Part 2. The Hole in the Roof. The South Atlantic Anomaly and why it terrifies engineers. The South Atlantic Anomaly was not discovered by a satellite. It was discovered by sailors. In the 19th century, as maritime traffic across the South Atlantic increased, navigators began reporting something odd. Their compasses behaved strangely in a broad zone, stretching roughly between the southern tip of South America and the southwestern coast of Africa. The deviations were not catastrophic. Ships did not sail off course into oblivion, but they were real, measurable, and consistent. Something was different about the magnetic field in this part of the ocean. For a century, that observation sat in the footnotes of magnetic survey reports, a curiosity rather than a crisis. Then the space age began, and the curiosity became a nightmare. When the first satellites and crewed spacecraft started flying in low Earth orbit in the late 1950s and early 1960s, engineers noticed a pattern. Every time a spacecraft passed over a particular stretch of ocean between South America and Africa, the electronics started misbehaving. Sensors generated false readings, cameras detected phantom signals, onboard computers, already primitive by modern standards, crashed, froze, or rebooted spontaneously. Astronauts aboard Skylab in the 1970s reported sudden flashes of light inside their closed eyes. Phosphenes triggered when cosmic ray particles passed directly through their skulls and interacted with the cells of their retinas. A cosmic ray doesn't need your eyes. It fires neurons directly. The cause was traced back to a peculiarity of Earth's magnetic geometry. Earth's magnetic axis is not aligned with its rotational axis. It is tilted about 11 degrees off, and on top of that, the geometric center of the magnetic field is offset from the physical center of the planet. The result is that the Van Allen radiation belts, those donut-shaped zones of trapped, highly energetic charged particles that surround Earth, are not symmetrically arranged around the equator. Over the South Atlantic, they dip significantly closer to the surface, descending to altitudes as low as 200 kilometers. 200 kilometers. That is barely above the threshold of low Earth orbit. That is where the International Space Station lives. Think of it as a structural defect in a building's roof. The main frame is solid. The building stands, the roof holds. But in one corner, there is a persistent low spot where rainwater collects and seeps through. Everything you put under that corner gets wet. For spacecraft, getting wet means getting bombarded with radiation that no amount of ordinary electronics hardening can fully deflect. It means cascading single-event upsets, individual bit flips in memory that can corrupt data or crash systems. It means accelerated degradation of solar panels, sensors, and circuit boards. It means shorter mission lifespans and higher replacement costs. This is not theoretical. The Hubble Space Telescope routinely suspends certain sensitive observations when it passes through the anomaly. The ISS has dedicated radiation shielding for its crew quarters specifically for traversals of this zone. Navigation satellites, communication satellites, Earth observation satellites, all of them accumulate radiation damage faster when their orbits carry them over the South Atlantic anomaly, which, for low Earth orbit, is several times per day. In 2007, the Globalstar satellite constellation suffered a series of anomalies and failures traced directly to radiation exposure during anomaly passages. As the anomaly expands, similar incidents will become more frequent, more severe, and more expensive. But here is where the story stops being about inconvenient satellite repairs and starts being about something far more fundamental. The anomaly is not static. It is growing, and it is growing faster than it was a decade ago. Part 3. Swarm, Data, and a Quiet Alarm. What ESA's satellites have been watching. In November 2013, ESA launched 3 identical satellites into polar orbit with a single purpose: to map Earth's magnetic field with greater precision than had ever been achieved. The mission was named Swarm. 11 years of continuous data later, Swarm has told us things that were previously impossible to know, and some of what it has told us is genuinely unsettling. Between 2014 and 2025, the South Atlantic anomaly expanded by an area equivalent to nearly half of continental Europe. France, Spain, Portugal, the Benelux countries, a significant chunk of Germany. Imagine all of that suddenly added to a zone of elevated radiation. That is the scale of growth in just over a decade. But the expansion is not uniform, and that non-uniformity is where things get interesting and alarming. In 2020, Swarm scientists identified a secondary core of weakening that had begun developing to the southwest of Africa, essentially a second minimum forming within the already weakened anomaly. The original center had been sitting roughly over the Atlantic Ocean east of South America. This new minimum was forming much closer to Africa. Professor Chris Finlay of the Technical University of Denmark, one of the lead authors of the research published in Physics of the Earth and Planetary Interiors, described the situation in words that any scientist understands carry more weight than they superficially appear to. The South Atlantic anomaly is not a single, uniform feature. It is evolving differently toward Africa and toward South America. Something particular is happening in this region that is causing the field to weaken more intensively. Something particular. When a geomagnetics professor uses the phrase something particular, he is not being whimsical. He is using the most carefully hedge-trimmed language available to academic science to communicate. We are watching something that our models did not fully predict, and we do not entirely understand why it is happening this way. Swarm's data also revealed the mechanism: reverse magnetic flux patches. This requires a moment to visualize properly because it is counterintuitive and genuinely strange. Imagine Earth's magnetic field as a vast lawn of tall grass. In the southern hemisphere, the magnetic field lines emerge from the core, grow upward through the mantle, burst through the surface, and arc outward into space before curving back down at the poles. That is normal. That is what the magnetic dynamo is supposed to produce: coherent, organized field lines exiting the core in the southern hemisphere and re-entering at the poles. But Swarm's measurements revealed that beneath the South Atlantic anomaly, something different is happening. There are patches of the core mantle boundary where the field lines are doing the opposite. Rather than emerging from the core, they are bending back and diving inward, as if the grass had somehow started growing with its roots pointing upward. The field has locally reversed direction. These reverse flux patches are not stationary. They move, drifting slowly westward toward Africa. And as they move, they cancel out the normal field above them, reducing the net magnetic field strength at the surface and in the overlying atmosphere. They are, in the most direct physical sense, the cause of the expanding anomaly. But what is causing the reverse flux patches themselves? Why is this happening here, under this region, and not uniformly across the entire planet? For that answer, we have to go deeper, much deeper. We have to go to the boundary between the liquid outer core and the solid mantle, 2,900 kilometers below where you are sitting right now, and we have to meet the blob. Part 4. The blob, a continent-sized monster at the bottom of the world. The official scientific name is the African Large Low Shear Velocity Province. The name is accurate but utterly unglamorous. It describes exactly what it is: a region beneath Africa where seismic shear waves travel more slowly than expected. Geophysicists, who are human beings with a sense of drama beneath the technical vocabulary, simply call it the blob. To understand how we know it exists, you need to understand seismic tomography. When a major earthquake occurs anywhere on Earth, it does not merely shake the surrounding region. It sends seismic waves propagating outward in all directions, not just across the surface, but straight through the interior of the planet. These waves travel at speeds that depend on the temperature, density, and composition of the material they pass through. Hotter, less dense material slows them down. Cooler, denser material speeds them up. A global network of seismometers records these waves. By analyzing the tiny differences in arrival times and wave characteristics at thousands of stations around the world, geophysicists can mathematically reconstruct what the waves pass through, essentially performing an MRI of the entire planet, using earthquakes as the imaging signal. What this technique has revealed is extraordinary. At the very bottom of the mantle, just above the liquid outer core, there are two enormous structures where seismic waves are significantly slower than the surrounding mantle. One sits beneath Africa, the other sits beneath the central Pacific Ocean. Both are enormous beyond ordinary comprehension. The African blob is approximately 1,000 kilometers tall, roughly 100 times taller than Mount Everest. Its horizontal extent spans several thousand kilometers. It is not small. It is not subtle. It is a continent-scale anomaly at the deepest accessible boundary within our planet, and it has almost certainly been sitting there for hundreds of millions of years, possibly far longer. What is it made of? We cannot drill to it, cannot sample it. We can only infer. One hypothesis: ancient oceanic crust subducted into the mantle over billions of years, accumulating at the base like sediment on the floor of an enormous aquarium. A second, more spectacular hypothesis involves the moon. About 4.5 billion years ago, a planet roughly the size of Mars, called Theia, collided with Proto-Earth in a cataclysm of incomprehensible violence. The impact vaporized both bodies partially, threw debris into orbit that coalesced into the moon and permanently changed Earth. According to this hypothesis, some portion of Theia never left. It sank to the base of the mantle and stayed. The African blob may literally be a remnant of a dead planet trapped inside ours for 4.5 billion years. A 2021 study in Nature provided partial support, suggesting the blob's anomalous density is more consistent with impactor remnants than subducted crust alone. The implication, that we are walking on a planet that contains pieces of another world in its basement, is difficult to process emotionally. Whatever its origin, the African blob's influence on the geodynamo is becoming clearer. A 2022 paper in Nature Geoscience established that the African blob is less dense and significantly taller than its Pacific counterpart, making it inherently less stable. It is not sitting calmly at the base of the mantle like a settled sediment. It is more like a giant bubble, slowly, inexorably working its way upward through the mantle. And as it does, it disrupts the convective flow patterns in the liquid outer core just above the core mantle boundary. Remember the dynamo. The geomagnetic field is generated by organized convection, coherent, large-scale circulation patterns of liquid iron driven by temperature gradients and planetary rotation. The blob is like a boulder dropped into the machinery. The system keeps running, but the output becomes uneven. The convection patterns near the blob's influence zone become distorted. And those distortions produce exactly the kind of reverse flux patches that Swarm has been observing beneath the South Atlantic. Places where the field lines fold back on themselves, locally canceling the normal field and creating the expanding zone of weakness that satellites pass through to their detriment several times every day. Part 5. Does any of this actually matter? Why the anomaly is not just an ocean. Away at this point, a reasonable viewer might reasonably object. Fine, the magnetic field is weaker over a patch of ocean between South America and Africa. There are no cities there. No humans live in that stretch of water. The fish and the seabirds don't file technical incident reports. Who cares? The answer is, you do, whether you know it or not. Let's start with the most concrete and immediate concern: the satellite infrastructure upon which modern civilization rests. Your smartphone knows where you are because of GPS satellites. The messages you send travel through communication satellites. The weather forecasts you check are assembled from data collected by weather satellites. The financial transactions you make, the electronic payments, the stock trades, the bank transfers, are synchronized by atomic clocks aboard timing satellites. Military reconnaissance, border monitoring, search and rescue operations, agricultural yield optimization, ship tracking, air traffic control. All of it runs through hardware orbiting in low Earth orbit, and all of that hardware passes through the South Atlantic anomaly multiple times every single day. Every pass through the anomaly is a radiation dose. Every radiation dose incrementally degrades components, increases the probability of a single event upset, shortens the operational lifespan of the satellite. As the anomaly expands, each pass becomes longer. Longer passes mean higher doses. Higher doses mean more failures, more frequently, sooner. This is not hypothetical. In 2007, the Globalstar satellite network experienced cascading failures linked to anomaly radiation exposure. Engineers who operate satellite constellations have entire mitigation protocols built around the anomaly. They shut down sensitive instruments during passages. They adjust orbits to minimize dwell time in the high radiation zone. They budget for accelerated component replacement. As the anomaly grows, those mitigations become more expensive, less effective, and less sufficient. And satellites are the minor concern. The major concern, the one that keeps certain geophysicists awake in a way that goes beyond professional interest, is magnetic pole reversal. Part 6. Reversal. The field has done this before, and before wasn't. Pretty Earth's magnetic field is not a permanent fixture. The geological record reveals a history of radical instability. Over the past 83 million years, the magnetic poles have reversed at least 183 times. North became south. South became north. The intervals between reversals range from 10,000 years to tens of millions of years, without obvious pattern. The last full reversal, the Brunhes-Matuyama transition, occurred approximately 780,000 years ago. By the average rate, we are overdue. But overdue for a geomagnetic reversal carries exactly as much predictive power as overdue for a major earthquake. You know one will eventually happen. You cannot know when. A reversal is not a switch being flipped. It is a process taking hundreds to thousands of years. The most dangerous phase is not the reversal itself. It is the transition. The field first collapses. The organized dipole structure breaks down. The field weakens to as little as 5% to 10% of current strength. In that weakened state, it fractures into a dozen or more regional poles scattered across the surface, appearing, wandering, fading, without the stable geometry we rely on. The magnetosphere, in this transitional state, resembles a colander. The solar wind seeps through everywhere. Charged particles reach the upper atmosphere across global latitudes, not just at the poles. Part 7. 42,000 years ago. The atoms event and what it cost the Earth. For decades, the scientific consensus held that magnetic reversals were essentially harmless to life. Earth had experienced over 100 of them. Complex life had existed through many without obvious catastrophe. Therefore, the reasoning went, there could not be a direct causal relationship between reversal events and biological crisis. Then came a 2021 paper in the journal Science that forced a careful re-examination of that comfortable consensus. An international research team led by Professor Alan Cooper analyzed kauri trees from New Zealand, trees that had been preserved for more than 42,000 years in the anaerobic conditions of ancient swamp peat, essentially perfectly pickled by their bog environment. By analyzing their annual growth rings with extraordinary chemical precision, the team was able to reconstruct what was happening in Earth's atmosphere year by year during the Lachlan excursion, a temporary, partial reversal of the magnetic poles that occurred approximately 41,000 to 42,000 years ago. The field did not fully reverse during the Lachlan event. It weakened dramatically, falling to less than 6% of current strength, and then recovered, all within a span of roughly 1,000 years. But that 1,000-year period of extreme weakness appears to have been anything but uneventful. The kauri tree rings showed a sharp, sudden spike in radiocarbon levels beginning precisely when the field weakened. Radiocarbon, carbon-14, is produced when cosmic radiation interacts with atmospheric nitrogen. More cosmic radiation reaching the atmosphere means more radiocarbon being produced. The spike in the tree rings was not subtle. It was dramatic. It said, cosmic radiation levels just went through the roof. The consequences cascaded. Ozone concentration in the upper atmosphere dropped significantly. Not because of industrial chemicals, this was 42,000 years ago, but because increased UV and particle radiation was destroying ozone molecules faster than they could be reformed. UV exposure at the surface increased across the globe. Climate patterns shifted. Ice sheets expanded in North America and Eurasia. Droughts intensified across Australia. Tropical forests contracted. And into this changed world stepped the hominins. The Neanderthals were already declining. The Lachlan event may have been the final environmental insult that pushed several vulnerable populations over the edge. In Australia, the megafauna were disappearing at the same time. Cooper's team proposed a provocative interpretation. Our ancestors retreated underground not merely to escape cold, but to escape radiation. The worldwide explosion of cave art, the handprints, the ochre animals, the geometric symbols, blossoms precisely in this period, across multiple continents, at roughly the same time. Perhaps these were not merely aesthetic expressions. Perhaps they were the record of a species learning to live underground. The researchers named this the Adams Event, a tribute to Douglas Adams, who specified that 42 is the answer to life, the universe, and everything. The timing, 42,000 years, seemed to warrant the joke. Not all scientists accepted the team's interpretation without question. Critics pointed out that the Lachlan event occurred simultaneously with a period of reduced solar activity, a solar minimum that would independently have increased cosmic ray penetration, and with the climatic deterioration of a glacial maximum. Disentangling the effects of three simultaneous stressors is extraordinarily difficult, and the critics were not wrong to push back. The U.S. Geological Survey remains formally on record, stating that there is no proven, direct causal link between magnetic reversals and mass extinctions. And there is the counterpoint of the Brunhes-Matuyama reversal 780,000 years ago, a full reversal, not merely an excursion, during which Homo erectus appears to have survived without obvious catastrophe. If they could live through a full reversal, perhaps modern humans could as well. But here is the crucial difference. Homo erectus did not depend on satellite networks, GPS-guided logistics systems, interconnected electrical grids, or any form of technology that becomes catastrophically vulnerable when electromagnetic conditions change rapidly. Part 8. The Carrington Event in a Weakened Field. A thought experiment about modern civilization. Let us run a thought experiment. On September 1st and 2nd, 1859, the most powerful geomagnetic storm in recorded history struck Earth's magnetosphere. Auroral displays were visible as far south as the Caribbean. Gold prospectors in the Rocky Mountains woke up in the middle of the night thinking it was dawn. The telegraph network went haywire. Some lines continued transmitting with their batteries completely disconnected, powered solely by geomagnetically induced currents. The entire global telegraph system was disrupted for days. If a Carrington-scale event struck Earth today, at current magnetic field strength, the estimated economic damage would run between $1 and $2 trillion, according to studies by the National Oceanic and Atmospheric Administration and the Lloyd's of London insurance market. We would lose satellites. We would lose transformers. Power grids in high-latitude countries, Canada, Scandinavia, northern Russia, would experience cascading failures that could take months or years to fully repair, because high-voltage transformers are not mass-produced items you can ship from a warehouse. They are custom-manufactured, heavy industrial equipment, each one taking over a year to build and costing millions of dollars. That is with the current field strength. Now run the thought experiment with the field at 10% of current strength, the condition that may have prevailed during the Lachamps event. The magnetosphere, already leaking in the South Atlantic, now leaking everywhere. The Carrington event arrives. Satellites navigating above low Earth orbit receive radiation doses that destroy their electronics outright. GPS fails globally. Civilian aviation loses the satellite-based navigation that now guides nearly every commercial flight. Shipping containers, which carry the vast majority of global trade by volume, lose the GPS tracking systems that manage their routing and scheduling. High-voltage transformers fail across multiple continents simultaneously. Electrical grids collapse in a cascade that takes not months but years to repair, because the supply chains to manufacture replacement transformers now require the electrical grids that just went down. Not the end of the world, but quite specifically the end of the world as we know it, the end of global logistics as it currently functions, the end of food distribution systems in their current form, the end of the financial infrastructure that synchronizes modern economic activity. This is why the South Atlantic anomaly is not a footnote. It is a warning light. Part 9. The field is redistributing the swarm data, Siberia, and the one-sided blanket. The weakening over the South Atlantic is not happening in isolation. Swarm's global mapping revealed that while the field weakens over the South Atlantic, it is simultaneously strengthening over Siberia. The magnetic North Pole, which sat in the Canadian Arctic for decades, has been moving fast. Since the 1990s, it has accelerated from roughly 10 kilometers per year to as fast as 55 kilometers per year by 2019. The area of strong field over Canada has shrunk by an area comparable to India. The area over Siberia has grown by an area comparable to Greenland. The field is not disappearing. It is redistributing, like a blanket being pulled from one side of the bed to the other. One side grows cold and exposed. The question haunting geophysicists is whether this is a stable rearrangement or the opening phase of something more disruptive. The tangling that precedes the blanket coming completely loose. Current data cannot answer that definitively. The world magnetic model, used by GPS systems, aircraft navigation, and smartphone compasses, had to be updated ahead of schedule in 2019 for the first time in its history because the pole was moving faster than predicted. It was updated again in 2020. These are not routine recalibrations. They are signs of a system changing faster than expected. Part 10. The Conspiracy and the Reality. Separating the frightening truth from the ridiculous fiction. No scientifically dramatic topic survives long on the internet without attracting conspiracy theories, and the South Atlantic anomaly has attracted some particularly creative ones. The blob beneath Africa is an alien base. The weakening field is preparation for extraterrestrial invasion. The pole reversal will cause the physical Earth to flip, continents flung to new latitudes, Antarctica on the equator. NASA knows all of this and is hiding the truth. This is what the title promised you. Here it is. The hidden truth NASA is allegedly concealing is that there is nothing to conceal beyond the straightforward, complicated science we have spent the past 15 minutes discussing. The physical rotation claim is completely, unambiguously wrong. Magnetic poles and geographic poles are produced by entirely different mechanisms. Geographic poles are determined by angular momentum and axial tilt, governed by orbital mechanics. Magnetic poles are determined by flow patterns of liquid iron in the outer core. They can reverse dramatically while exerting zero physical torque on the solid Earth. The continents are entirely decoupled from the liquid core magnetically. They do not move in response to magnetic reversals. They never have. They cannot. Swapping a car battery's terminals does not make the engine run backward. The Bermuda Triangle version, the anomaly causes ships and aircraft to disappear, contains a grain of truth surrounded by fiction. The anomaly does affect spacecraft electronics at altitudes of 200 to 600 kilometers. Earth's atmosphere provides ample shielding for anything at sea level or normal flight altitude. You can sail through the anomaly's geographic footprint on a cruise ship with complete safety. The only hazard is the weather. Part 11. What we actually don't know and why the honesty is more unsettling than the speculation. Here is the part that scientists find genuinely difficult to communicate without either alarming people unnecessarily or giving false reassurance. There are fundamental things about Earth's geodynamo that we genuinely, honestly, structurally cannot predict. Geomagnetic reversal is a product of nonlinear, chaotic fluid dynamics in a system we cannot observe directly, cannot sample, and can only probe with seismic waves and surface magnetic measurements. The equations that govern the behavior of the geodynamo are the same Navier-Stokes equations that govern turbulent fluid flow in general, equations for which we do not have complete analytical solutions, and which, even with the most powerful supercomputers available, cannot be perfectly simulated at the scales relevant to Earth's outer core. Predicting the future behavior of the geomagnetic field a century from now is, in the assessment of multiple leading experts, approximately as reliable as predicting the specific weather at a specific location 1 year from now. Directional trends, yes. Specific behavior, no. What we know with confidence, Earth's overall field strength has declined approximately 9% over the past 170 years. The South Atlantic anomaly has been expanding continuously since at least the 1970s. The rate accelerated after 2020 with the emergence of a secondary minimum southwest of Africa. The magnetic North Pole has been drifting at historically anomalous speeds since the 1990s. The blob is not going anywhere. It has existed for hundreds of millions of years. What we genuinely do not know, whether these changes are leading toward a full reversal, a partial excursion, a continued slow weakening, or a temporary fluctuation. Whether the blob's current activity is a new development or an ordinary oscillation in its million-year behavior. Whether the 9% decline represents a long-term trend or a temporary dip. The Swarm mission, originally planned to operate until 2017, has been continuously extended because its data has proven too valuable to interrupt. As of 2025, ESA has approved swarm operations through at least 2028 and is planning for a follow-on mission with even more sensitive instrumentation. Scientists are not extending this mission because everything looks fine. They are extending it because it has become genuinely important to watch what happens next. A 2020 paper published in the Proceedings of the National Academy of Sciences offered a potentially reassuring finding. It identified evidence in the geological record that the South Atlantic anomaly, or anomalies similar to it, have appeared and disappeared repeatedly over at least the past 11 million years in the same geographic region. This suggests that the anomaly may be a recurring feature of the geodynamo, a chronic tendency of the system in this region, rather than a novel development heralding imminent catastrophe. If that interpretation is correct, the anomaly is more like a chronic condition than a terminal diagnosis. It will wax and wane. It will occasionally cause problems. It will not precipitate the end of civilization. But even if no reversal ever comes, the current level of anomaly expansion is already producing measurable, expensive, consequential effects on the satellite infrastructure that underpins modern civilization. And if the trend continues at its current pace, those effects will scale. A South Atlantic anomaly that is twice as large means every low Earth orbit satellite spends twice as long in elevated radiation during each pass. That means accelerated degradation across every satellite system on the planet. That means higher costs, more frequent failures, shorter operational lifespans, and an increasing gap between the durability of our space infrastructure and the demands we are placing on it. Part 12. The Planet Beneath Our Feet. On living with an impermanent shield, consider the larger picture. We live on a planet whose surface is a thin crust of broken rock, floating on semi-solid mantle, itself floating on an ocean of liquid metal nearly 7,000 kilometers across. Inside that ocean, currents of liquid iron circulate at tens of kilometers per year, organized by heat and rotation into the largest electrical generator in the inner solar system, producing a magnetic field extending thousands of kilometers into space. At the very bottom of the mantle, two continent-sized blobs of dense, strange material, possibly remnants of an entirely different planet, disturb those iron currents. The disturbances ripple upward through the mantle, through the crust, through the atmosphere, and manifest as the South Atlantic anomaly, a zone where Earth's protective field is thinner, where radiation reaches lower, where spacecraft fail, where the boundary between safety and exposure retreats year by year. This field is not eternal. It was not guaranteed. It has changed before. It will change again. Earth's magnetic history is not a story of steady protection. It is a story of fluctuation, reversal, temporary failure, and recovery, repeated over timescales so vast that no species has ever had to contend with a full cycle. Until possibly now. We are the first species in the history of Earth that has built technological civilization, while the magnetic field is undergoing documented, measurable change. We are the first species that can detect that change, model it, debate its causes and consequences, and theoretically act on the information. Our predecessors, Homo erectus, who survived the Brunhes-Matuyama reversal, Homo sapiens, who took shelter in caves during the Lachant excursion, had no warning systems, no satellites, no models, no conferences. They endured. They adapted. They did not plan. We can plan. That does not mean panic. Panic is not planning. Panic is the absence of planning, the collapse of deliberate thought under emotional overwhelm, the human equivalent of running from a fire without noting which direction the exits are. The South Atlantic anomaly does not require panic. It requires attention, sustained funding for monitoring missions like Swarm and its successors, investment in radiation-hardened satellite technology, development of ground-based navigation backup systems for the scenario where GPS becomes unreliable, and long-term planning for the protection of high-voltage electrical infrastructure against geomagnetically induced currents. None of these preparations are exotic. None of them require classified knowledge or conspiracy. They are the ordinary application of engineering caution to a well-characterized risk, the same kind of caution we apply to earthquake-resistant building codes in seismic zones, flood barriers in coastal cities, and fire suppression systems in data centers. The planet does not owe us stability. It never did. The geologic record is unambiguous on this point. Earth is a dynamic, violent, constantly changing system that happened to produce, in a brief recent window, conditions stable enough for a technological civilization to arise. That window has not closed, but it is not guaranteed to remain open indefinitely, and several of the processes that could narrow it are measurable, visible, and ongoing. We have the instruments, we have the data, we have the physics, we have the engineering capability. What we need, above all, is the sustained will to take the long view, to treat a slowly evolving geophysical threat with the seriousness we reserve for immediate crises, even when it will not fully manifest within any individual election cycle, business quarter, or human lifetime. Because the blob has been there for hundreds of millions of years. It will be there long after every satellite we have ever launched has fallen silent and re-entered the atmosphere. But the civilization we build in response to the information it has given us, that could last just as long if we are willing to build it carefully. Write in the comments what struck you most. The continent-sized blob sitting at the bottom of the mantle, the rivers of liquid iron flowing backward beneath Africa, the 42,000-year-old trees that preserved the moment Earth's shield nearly failed, or the fact that we are living right now in a period when the magnetic field of our planet may be beginning one of its grandest and most consequential transformations. I hope you enjoyed the video. If you did, please hit the like button. It genuinely helps this channel reach more people who care about understanding the world as it actually is, not as we would prefer it to be. Subscribe if you want to keep going deeper into the science that shapes everything we know. We are just getting started.